Hey guys, we are finishing up our 6.7 notes, so you should already have this front side filled in, and we're getting ready to do the back side. So the natural logarithm is basically the natural logarithm x is written as ln x. So you might have seen this before. It is a button on your calculator too. It's right underneath the log button right here. It does kind of look like it's IN in a problem. It's an L, not an I. And don't ask why, but it should be NL for natural log. It's just written in the backwards order because it comes from a translation of another language. And it has a base equal to E. So just a reminder that E is the value 2.718 approximately, and it comes from something called continuous interest. And basically what we're going to do is just work with this a little bit. Over here, because the natural log has a base of E, remember that anytime a log has a base and a inside piece that has the same base as over here, so these two E's, the natural log of base E and this E cancel out, and it's just 5x. Another way of writing this is you are allowed to put the powers out front instead of in the middle like that. So you have 5x times the natural log of E. And E to the first power is E. So this just turns into 5x times 1, which is 5x. And you don't have to write it out like that every time. Just know that the ln and the E cancel each other out, which means that on this one, the ln and the E cancel, and this part is just 2x. They also cancel if the E goes first. So E to the power of the natural log cancel, and that's just 7x. And 2x plus 7x is 9x. Then, over here, this one's a little tricky because it doesn't go directly from E to the natural log. There's this 3 in the middle. Don't forget that that is just a power. So this could be a power on x plus 5. So now it does go directly from E to the natural log. Those cancel, and it's x plus 5 to the third power. And I'm going to zoom in because I realize that that's a little hard to see, if that helps. Sometimes I forget that not everybody has a paper copy of this with them. And we're not going to solve what that is. We're just going to leave it like that. That's our answer. And now let's look at some equations that have it. So my tips to you always with solving equations that have exponentials or logs is to isolate first. So get e to the x or the natural log of x by itself first. And if you get stuck, try converting between exponential and log form. So for example, on 8, we want to put these two together. So that's going to become the natural log of 4 divided by x. Because when you are subtracting two logarithms, you can combine it into one by dividing the two insides. Then I'm going to give it the base of e back for a second, because there's always that imaginary e whenever it says ln for the natural log. And we're going to convert to exponential form. We're already in log form, so we're going to try and get out of log form to see if that helps us solve it all. Because there's not a whole lot more I can do with this since I don't know what x is. So I'm going to have e to the power of 7 equals 4 over x. And then I don't like it when there's a fraction, so I'm going to multiply by x on both sides so that that cancels out. And what I have right now is x times e to the 7th equals 4. And I'm not actually doing e to the 7th power because I don't want that decimal just yet. I don't want the decimal until the very end of my problem, so I try and wait as long as possible. Now, if I want to get x by itself, I divide by e to the 7th power. So essentially, x equals 4 over e to the 7th power, which is 4 divided by e to the power of 7. .0036. And you'll see a lot of decimals in this section because of the e. Okay. And then we're going to move on to the next one. So you'll notice that there is an e to the power of 2x. We want that to be by itself. So I'm going to get rid of that 7. And then I don't know how to get x, or find out what e to the power of 2x equals 16. I don't know how to find out what x is. So I need to get it out of this form. When you get stuck like this, that's when you want to try and convert. Converting is almost always the answer. So this is where you're going to have, this is the base of your logarithm. This is the part next to it. And remember that the power is the answer to a log. You can also draw this cloud, base e of 16 equals 2x, to help you remember what order they're supposed to go in. And then this is just ln of 16 because it's log base e. And to get x by itself, we just need to divide by 2. So x is equal to the natural log of 16 over 2, which is 1.39. Now, I normally round to 2 decimal places. The reason why I didn't on example 8 was so that I would actually have some of my numbers and I wouldn't lose all of them. Okay, and then we have example 10, which is being subtracted. When you are subtracting 2 logs, just like this one, you divide those. They do have to have the same base, and since they are both natural logs, that is already true. And then nothing changed about the right side. Don't forget that when you have 2 logs of the same base on both sides, those just cross out, and you're pretty much just solving the equation 5x minus 3 over x plus 5 equals 3. When you have a fraction that involves variables, or when you have a fraction that you want to get rid of, just like I did over here where I multiplied by x to cancel it out, I'm going to multiply by x plus 5 on both sides so that these two can cancel. And I get 5x minus 3 equals 3x plus 15. And this is just a regular equation left to solve. I'm going to minus the 3x, and then I'm going to get rid of this negative 3 by adding it. 5x minus 3x is 2x. 15 plus 3 is 18. If 2x equals 18, that means x equals 9. And then we have one last word problem down here. How long will it take for an investment to triple in value if it is compounded continuously at 3%? This is continuously, which means we're using this formula right here. One issue with this one is it tells you the percentage, so that's 0.03 t. We don't know how much time there is, but part of the issue is it wants you to triple the investment, but it doesn't tell you how much. Pick a number. Let's say we're going to invest $1,000. Then triple that investment would be $3,000. It doesn't matter how much you pick to start with. It's going to take the same amount to triple an investment of $1,000 as it takes to triple an investment of $2. It's just a lot more money to triple 1,000 than 2. So let's say I'm starting with 1,000. I would then end up with 3,000. So I'm just guessing. I'm just taking a pick on my own. Doesn't matter how much you pick. It is a little bit easier to work with if you pick a bigger number sometimes because it makes a little bit more sense to your brain. So we need to get this t out of here. The first thing that I know I can do is that these are being multiplied, so I can divide by 1,000 on each side. And that's why it didn't matter how much I picked, because since I tripled it, this is going to equal 3 no matter how much I actually had, because this is just this times 3. And then we're stuck. We don't know how to get that out of the exponent, except we can use the log like we did here. So we're going to have log base e, because they always have the same base, of 3 equals 3/100 t. Remember that when you switch to log form, the power or the exponent becomes the answer on the other side. And then this is log base e, so we can switch that to the natural log. And we're going to divide by 0.03 on both sides. ln 3 over 0.03. So it would take 36.62 years. So about 36 and a half years to triple this investment. But it's only going up at a rate of 3%, which isn't very high. So that makes sense that it would take a while. Also, you're going from $1,000 to $3,000, so that's quite a bit of money.